Section 6.4 is on inductors, so that's our second charge storage element that we talk about in EE210. An inductor has a core with a conducting wire turned around it. And we say that it has N number of turns. The core area is A, and the length is L. Our circuit symbol for an inductor is this squiggle type of thing, and we represent an inductor with a capital L. So lowercase l, that's the length of the core. Uppercase L, that's the inductor value. So from this, we get V equals L di dt. L is our inductance, and it's measured in henries, or a capital H. Now again, if we integrate this, we will get the energy stored. So integrate to get energy stored. And that is W equals 1/2 Li squared. So just like our capacitor, our inductor has a couple special notes that we want to look at. One is its behavior in DC. In DC, an inductor acts as a short. So wherever you see an inductor in a DC-only circuit, you can replace it with a short circuit. So remember, that's just saying, here's our inductor. I can replace it with a wire, a short circuit. That gives us a 0 voltage, right? If we have a short circuit, that's a V equals 0. An inductor current must be continuous. So with capacitors, we talk about voltage. Voltage cannot abruptly change and must be continuous. In inductors, we talk about current. Current must be continuous and cannot abruptly change. And that will come up more in Chapter 7. So Section 6.5 is on series and parallel inductors, and it's really simple because they act just as resistors. Act like resistors mathematically. And again, there's a proof in your book of why this is, but we're going to skip that. So in series, an equivalent inductance, we just sum the inductors. Again, just like a resistor. And for inductors in parallel, it's the reciprocal of the sum of the reciprocals. There's a table in the book I want to point out, table 6.1, and it really sums up the characteristics for inductors, capacitors, and resistors nicely. So that's a table you'll want to take note of and remember where that one is. And this will conclude Chapter 6.